Okay, Assalamualaikum and a very good evening. It's now 5:20, yeah, almost 5:20. Yeah. So today's class, we're going to do questions that is related to rigid body. So one question is using the principle of work energy, and the other one is using principle of unit impulse and momentum. Okay, so we have gone through one example yesterday and we have gone through the concept. So now let's just try some exercise because I think you need a lot of practice. From what I heard, your test one, maybe many did not do so well. So let's try to do more exercise together so that we can improve in our um, marks. Okay, so this is let's do the first example first. So I will put this as a example aside dulu kejap. Okay, all right now. Okay, now have you done this example? Actually, I already asked you to do this example, but I believe mungkin yesterday was our class. Maybe some of you did not have the time. Did you manage to do or not? Not yet. Adienda.
No.
No, okay, so never mind. I expected that answer. So today we're going to do this question. Okay, now a 120 kilogram block is suspended from an inextensible cable which is wrapped around a drum of 0.4 meter radius rigidly attached to a flywheel. Okay, now the drum and flywheel have a combined centroidal moment of inertia. So dia dah bagi tahu dah I berapa So dia dah bagi tahu I berapa. So usually I like to write what information I have. Okay, so I is 16 kilogram meter and the radius of the radius is 0.4. That's alright. Now, at the instant shown, the velocity of the block is 2 meter per second. So we know at the instant shown, the velocity of the block is 2 meter per second. So do you think that is V1 ke V2? Bila dia bagi tahu at the instant shown.
V1.
Yeah, so we can say that V1 is 2 meter per second. Now it says the block is directed downward. So we know this block is directed downward. Okay, the V is directed downward. Knowing that the bearing at A is poorly lubricated, okay, and that the bearing friction is equivalent to a couple M moment of magnitude M. So dia dah bagi M. Okay, kat sini dia kata M is dia ada bagi hint. Dia kata M ni adalah poorly lubricated and dia ada friction, bearing friction. So it means dia mesti direction opposite of the direction of the wheel. Okay, now if this block is should be going down, now so the wheel should be moving. If the block needs to go down, the wheel should be going clockwise direction ke anti-clockwise?
Anti-clockwise.
Anti-clockwise. So it means when it's anti-clockwise, we know that the omega direction is this way, okay, which is anti-clockwise, okay, because the wheel is going down. But now it says there is a bearing friction couple moment. So now the bearing friction couple moment, because it's a friction, we can assume that is the opposite direction. So we can say the couple moment M is in the opposite direction, which is M equals to yang tadi lah, 90 meter. Right. Okay. You need to actually read the question carefully. Okay. Now, determine the velocity of the block after it has moved 1.25 meter downward. Okay. So it means they want us to find V2. What is V2? Okay. When S2 is 1.25 meter. So we can say that S1 we assume to be starting 0 lah. Okay, so these are all the information that we have, and we have the mass of the block is 120 kilogram juga lah. Jangan lupa info tu. Okay, now, so these are all the important information that is given for us. So what they asked to determine is they suruh determine V2. Okay, so basically when you read this question, do you know what principle you want to use? Do you want to use principle of work and energy, or do you want to use impulse and momentum? Which one you want to use? Obviously, because it involves displacement of the block 120 kilogram, it means you have to use principle of work and energy. So you need to use principle of work and energy because the block is displaced. Now, Now, what is principle of work and energy? Okay, we remember it is T1 plus work equals to T2. Okay, now, what is the value of T1? Is T1 0? Yes or no? What is T1? T1 has a value because the
Ah,
question it doesn't say starting from rest. You already said it has a instant apa velocity. Okay, now for this question, okay, what we can see, we have a block moving up and down. So it means for the kinetic energy, we will consider 1 over 2 mv squared. And because we also have a rotating apa ni fire wheel ni yang rotating ni, yang drum ni rotating ni, so because of that we also need to consider the rotation, so it will be 1 over 2 I omega squared. Okay, so this is how you decide what is the kinetic energy involved. Okay, so these are the two things that the type of kinetic energy that is involved. Okay, so that is for T1. Okay, so it will be the same for T2. Okay, but now let's see. Okay, let's write down the information we have. 1 over 2, and what is the mass of the block? 120. What is the velocity of the block? V1. So this is for V1. So
2.
V2, yes. V1 is 2 squared plus 1 over 2. What is I? Okay, for this question, I is given already. So you don't have to calculate, which is 16. Multiply by omega. Do you have omega?
No.
But can you find omega? Remember
Can.
this. Okay, what formula? Mr. Ken.
V equals to R omega.
V equals to R omega. So if you want to find omega, it will be V divided by R. So our V is 2 and then our R is 0.4. So we can 2 divided by 0.4, you will get 5 radian per second. So you can just replace here as 5 and then square. So can you please calculate for me what answer you get for the kinetic energy? The answer should be in joule. What do you get?
440.
Okay. So you get 440 joule. Okay, now we're going to do the same for T2. So T2, again, 1 over 2. The mass is the same, 120. Okay, V2 is what we want to find. Okay, so that will be our unknown. 1 over 2. I is the same in moment of inertia I. And what would be the omega? Okay, now, it's the same formula. Omega equals to V over R. Okay, but our V is V2. which we do not know. Our R is the same. So our answer will be in terms of V2 over 0.4 radian per second. Okay, it will be in terms of that. Okay, so V2 divided by 0.4 square equals to, okay, so what is the answer? If you simplify this, your answer should be in terms of V2. Okay, your answer should be in terms of V2 squared joule also. Okay, what is it? Can we calculate for me? 1 over 2 times 120 dapat 60 plus apa-apa 8 divided by 0.4. What do you get the answer?
110 V2.
Okay, so 110 Okay, good. Okay. Now let's do the work. Okay, now. What do you think the type of work is involved in this question? Can you guess?
Due to weight.
Okay, good. One is due to weight. That's correct. And the other one?
Moment.
Okay, due to the bearing friction couple moment M, due to moment, Okay, now. Okay, now. Okay, this is something, okay, that I want to highlight here. Okay, remember due to weight, the formula, what is the formula? Negative
Negative W.
W S2 minus S1. Okay. Now for this question, S2, where would S2 be? Let's say this is our original position and now it has moved down. Okay. Okay. So our original position is S1 is here and here is S2. And we know that this here is equal to
1.25.
1.25. So what we can say is our so what can we say? So let's say we according to height lah, arah Y ke atas ni kan, and then this is the bottom right. So we can say that our S1 is 1.25 and then S2 is 0. Okay, alright, so this if you follow this formula direction lah, sebab ada juga dalam buku, dia tak menggunakan formula tu, whereby dia use this formula. It's the same, but dia punya pemahaman lain. W S2 minus S1. Sebab dia terbalik. Yang macam ni terbalik. Yang ni condition ni, condition ni terbalik. Di mana dia consider ini to be S1, ni to be S2. Tapi if you are familiar with this one, I think you should follow this one. Sebab soalan-soalan yang sebelum ni exercise kita buat, bila dia sampai kat bawah, kita assume dia zero kan? So that's why kita tak negatif kat depan ni. So this one is another way of assuming lah, tapi dia terbalik. So just follow one method that is comfortable with you. Since I dah ajar you yang method yang ada negatif W2, you just keep it consistent lah. So due to weight, dia akan jadi negatif W S2 minus S1, and then due to moment dia negatif sebab dia friction moment so friction moment, and then dia ada theta 2 tolak theta 1 lah. Okay, alright, so negatif M adalah W adalah mg, M adalah 120, G adalah 9.81. Okay, so what did I say? S2 adalah kosong, S1 adalah 1.25. Okay, tolak M. M is given as apa tadi? 90 ya? Okay, M is given as 90. Okay, so theta 2 minus theta 1. So kita assume theta 1 is 0 ya. So theta 2, dia ada bagi ke theta 2? Okay, dia tak bagi lagi. So kita kena cari. Okay, do you think you can find theta? How to find theta dalam sebutan S? Because sekarang ni our weight dalam sebutan S. How to find theta dalam sebutan S? Kita kena make sure ni dengan ni sama. What is, macam mana nak jadikan theta dalam sebutan S? Remember this formula? S equals to R theta. Remember that? Hello, ingat
Yes.
tak?
Yes.
Okay. So theta equals to S divided by R. So what is our S? Our S ialah 1.25. Our R adalah 0.4. So it means our theta is 1.25 divided by 0.4. What do you get?
3.125.
Okay, what is the unit? Okay, you
Radian.
always miss updating the units. So this is our theta 2. Our theta 1 is 0 lah. Okay, minus 0. So tak payah letak. So can you find me the answer? So ni minus 120 nanti multiply dengan minus 125 dia jadi positif lah. So what is this answer? Work also answer should be in joule. What is the answer?
One 1190.25 joule.
Apa dia? One?
1190.
Okay, 1190. Okay. So now we have all the values. You think you can find V2. So you can find V2. So very simple. All you need to do is put into the equation T1 plus work equals to T2. So T1 is 440 joule plus 1190 joule equals to 110 V2 squared. Okay, so from there you can find V2. So what is your answer for V2? And your V2 will be in meter per second. Okay, what is your answer?
3.85.
Okay, now what is the direction of the velocity? Is it going up or down? It going down, right? Because dia dah cakap dah, the velocity, because you get your answer positive, so you know the assumption, the direction, where the velocity asalnya dia kata going down is correct lah. Okay, in case you dapat negative, the direction dah berubah lah. Okay, alright, so that is how to answer soalan uji
Betul.
body that is related to work and energy. Okay, now we're gonna move.
Doktor, kalau yang
Yes.
joules tu kan tak payah ambil decimal point.
Dia ada decimal point. Boleh? Dia susah nak cakap lah. Ada student letak, ada student tak letak. Kalau nak selamat, kalau you rasa nak letak, letaklah 2 ke decimal point ke. Boleh?
Okay.
Alright, now. Okay. So that is how to do principle of work energy. Okay, so I'm fine. There are more examples in the book textbook that you need to try. Okay, now this question is another question. Okay, all right. Okay, now, okay, let's do this question. Okay, all right. Okay, now. Okay, this question looks a bit very similar dengan question sebelah, but let's read it now to understand. The cylinder B shown in figure has a mass of 6 kilogram. Okay, now let's write that down. Cylinder B. Okay, so mass B is 6 apa? Kilogram. Okay, now it is attached to a cord which is wrapped around a periphery of 20 kilogram disc. So ada mass disc jugalah. Okay, so the mass of the disc is 20 kilograms. That has a moment of inertia. So dia dah calculate the moment of inertia, which is 0.40 kilogram meter square. Okay, if the cylinder is initially moving downward with a speed of 2 meters per second, so very similar question, they're moving down with the speed of 2 meters per second, determine its speed in 3 seconds. So dia nak determine its speed at 3 seconds. So basically, what do you think? V1 is obviously 2 meter per second lah. Dia suruh kita cari V2 lah. Okay, tapi dia suruh cari V2 when T equals to 3 seconds. Now, when you see this type of question, what do you think? What method you want to use to solve this problem? Now, nampak?
Impulse.
Impulse. Why? Because
Sebab ada time.
yes, because they give you the time. Because if you use word energy, it's not there. Okay. So now, now you remember the formula of impulse is L1 plus impulse equals to L2. Okay, now, but before we do this question, we need to draw a little bit of the free body diagram. Okay, so now, okay, if I ask you what is causing motion, what is causing motion in the diagram? What do you see is causing motion? Number one is the cylinder. Number two is the disc. So there are two things that is causing motion. Two things that is causing motion. It's the cylinder and the disc. So it means you need to write these two equations. One equation impulse for the disc and the other equation impulse for the cylinder. Okay, now let's do one by one. Let's write the principle of impulse and momentum for the disc. Okay, but before that, we need to draw a diagram. Okay, so let's draw again the disc. Okay, all right. So this disc, of course, it has what you call a weight. Weight dia mesti mg lah. M dia berapa? M dia 20. So 20 kali 9.81 dapat berapa? Ada calculator tak?
196.2.
Oh, okay. Dah calculate dah. So 196.2 Newton. Okay. So dekat support A ni dia ada, of course dia ada AY, dia ada AX, okay. And then kita tahu dia ada radius. Okay, radius dia berapa? 0.2 meter. Kita tahu tu. Okay. Now, so for this question, okay, because it's a motion of the cylinder and the disc is separately, so the cord, this will be the cord, kita ada cord tension, dia mesti pulling, so this is tension punya behavior. Okay, dia pulling. Okay. And then ada the block balik. So this is how you draw the tension, and then we have the block. Wait, the block is 6 6 kali 9.81 berapa? Dapat berapa?
58.86.
8.8. Velocity is going down, our velocity of the block is going down. Okay, now so now we need to write the equation, one for the block and the other one for the disc. One for the cylinder. The block is the cylinder lah, and the other one is the disc. Okay, boleh kat sini sikit lah, gerak sikit diagram. Okay, so first kita buat for the disc. Okay, now for the disc, okay, remember the disc formula for L, dia ada dua kan, satu MV, lagi satu apa, I omega. Tapi for the disc, what is happening to the disc? Dia only rotating, am I right?
Yes.
So for the disc, kita punya Li yang kita nak consider, kita tulis balik formula tu The Li that we are going to consider is only considering I omega only. Okay, because they're rotating. Okay, and then kita ada impulse. Okay, now impulse yang kita nak consider kat sini apa? What do you think? Impulse due to what? The disc. Okay, so impulse due to this disc ni kita boleh consider the force T ni moment from the force T. So it means T kali force T kali 0.2. So kita boleh consider moment Okay, you ingatkan moments kan force multiply by distance So kita boleh buat M. Okay, due to time dt equals to I omega 2. Okay, what is I? Okay, I dia dah bagi So I sama which is 0.4. What is omega 1? Do we know what is omega? Kita tak tahu what is omega Okay. Now, what is the moment? So we tahu moment is the force T multiplied by R. Okay, perpendicular distance R dia, which is 0.2. Okay, now because dia adalah integration of time, so time tu kita letak multiply by 3 seconds. Okay, equals to, again I dia dah sama and omega 2. Okay, now kita tahu tak what is omega 1, omega 2? Kita boleh cari tak? Yes or no? Boleh cari ke tak? Remember formula V equals to R omega. Do you think you can find omega? Yes or no? Can. Okay. So what is omega? Omega will be V divided by R. Okay. So what is omega? Omega 1, what will be omega 1? Omega 1 will be V. What is our V? What is our V1? 2. So our R is 0.2. Okay, 2 divided by 0.2 berapa? 10 kan?
Yes.
Okay, 10 radian per second. So that is our omega 1. How about omega 2? Omega 2, do we know what is V2? We do not know. Again, we do not know. And then after that, we must divide 0.2. So 1 divided by 0.2 adalah V5 lah. Okay, V2. Okay, again, ni radian per second Okay, so it means kita boleh letak tu dalam equation balik kejap lagi Okay. So we can write that in the equation. Okay. You all boleh buat letak dalam equation tu. Okay. Lepas tu, okay, taklah kita buat sama-sama lah. Okay. Now, that is for the disc. Now kita nak do the cylinder. Just cylinder pun tak. Now for the cylinder. Okay, now for the cylinder again. Now for the cylinder yang ini yang ni, the cylinder macam bentuk macam ni Okay, this is the cylinder cylinder lah. Okay, selalunya kita guna block cylinder atau block Now, what kind of linear momentum that you nak consider for the cylinder? Do you want to consider mb plus I omega ke mb saja ke I omega saja ke dua-dua?
MV.
MV saja. Yes, that is correct. So now you know what to do. As long you know what to do, that is correct. Okay, now again. Okay, so for the cylinder, kita tak ada tak ada radius involved so kita tak boleh consider moment. So kita consider force So kita buat summation of forces dt equals to MV. So kita ada MV1, MV2. Okay, so our M kat sini berapa? What is our mass?
Six.
Okay, 6. Okay, wait. Before that, I tertinggal. When you write down this equation, you must have a direction of movement, how you assume. Okay, now go back to the diagram atas ni. Now, okay, now since our okay, since our block is going down, what is the direction of the omega? Clockwise or anti-clockwise?
Clockwise.
Okay. So you need to draw that. Tadi kita tak draw. Kita need to. Okay, right. Okay. So you draw it clockwise. So it means this assumption yang you buat omega semua positif ni is because you have assumed that clockwise is positive. This is the assumption you have assumed. You can write it down. Sometimes you can make mistakes in the calculation due to the direction of the assumption saja. Okay, now so for this one, okay, it doesn't matter. Kita boleh assume up positive, bawah positive. So but usually selalunya kita always assume going up positive. Tapi if you get the answer negative, your early assumption is terbalik lah, itu je. Nothing wrong. This is the assumption. Okay, now since we are assuming going up positive, so our mass and velocity ni, our mass is berapa? 6 Okay. Now our velocity is going down, right? Down berapa? 2. Tapi kita punya assumption kat sini up is positive. Okay, so kita need to put negative sign here because it's the opposite direction with our assumption. Okay, plus dengan T multiply dengan 3 seconds equals to okay, T, okay, mana okay, now for the cylinder kita ada 2 sekarang ni for this one kita looking at this diagram here. Okay, sekejap. Let me highlight. Sekarang ni kita sekejap oops. You need to look at the diagram here. Okay, now it's not only T multiplied by 3 seconds. What is it? What else we need to multiply? Negative 58.86 multiplied by 3. So kalau you perasan, because our tension is going up, so it's positive, and our weight is going down, that's why kita put a sign negative there. Okay, equals to our mass. Okay, our mass, which is negative 6 kali dengan VB. Okay, VB, which VB pula, what is it? V2. Okay, now, so you have these two equation in front of you. Okay, kalau you notice both of these equation, this is your first equation and this is your second equation. So tolong solve simultaneously and get me the answer of the, sekarang ni dalam soalan ni diminta apa? Determine its speed in 3 seconds. So it means the question dia nak V2. Okay, tolong give me the answer. So the answer should be in meter per second. Okay, tolong calculate. Dapat berapa? Dapat berapa? Tengah kira lagi ke?
Tengah kira betul. Jom.
Okay. So you need to apa? Solve the equation simultaneously. Yeah. I hope you're using a calculator. Yes, what do you get?
Saya dapat 13. Betul ke?
Betul?
Sama, dapat 13 juga.
Okay, now, so you dapat positif, eh? So it means where the direction, the assumption going down
Upwards.
is upwards.
Downward Okay.
Bila you dapat positif, apa assumption you tadi? Going downwards kan? So the direction tu betul lah. Kalau you dapat negatif, it means the earlier assumption tu going downwards tu terbalik. So it's correct lah. So 30 meter per second. So betul. Okay, alright, good. So I think now you understand the difference of these two questions. Both are somehow similar, but one is using principle of work and the other one is using impulse and momentum. Soalan dia pun berlainan sikit. Okay, so what I think you need to do, macam ni je, very simple je apa yang nak you buat. You go through all the tutorial questions that have been suggested for you for these topics. You tak perlu, let's say you jangan mula buat jalan kerja dulu. Don't start doing any solution. You just write down the variables given and you write down, okay, let's say you write down the equation of principal work energy. What kind of kinetic energy yang you nak guna? Are you going to consider 1 over 2 mv squared plus 1 over 2 I omega squared ke, or only 1 over 2 I omega squared? You decide. And then after that, what type of work is involved? Is it due to weight, due to moment, due to spring? You write down. Okay, as long pada you know what you are doing, then it won't be difficult for you during the test. Okay, so tak perlulah beria buat spend 1 jam, 2 jam buat. Just go through all the examples and try to tengok, okay, for this question, but before you look at the solution, you kena fikir dulu sendiri. You kena test yourself whether you really understand ke tak. Okay, macam tadi bila saya tanya, okay, you tak tengok solution tapi you boleh jawab kan. So saya nak macam tu, you practicekan macam tu. So nanti cari lagi soalan linear impulse or momentum, you cuba tengok, okay, for equation Li nak pakai apa? MV ke, I omega ke? You decide, okay, for the impulse, apa yang I nak consider dalam solution ni. As long you tahu apa parameter you nak letak, you should be fine. Okay, itu je yang penting. So you try to browse all the exercise and cuba you just bincang macam tu. Buat macam tu. Tapi macam I cakap lah, jangan tengok solution. Cuba buat dulu. Buat dulu nota kecil-kecil. Just macam uh, apa you rasa this is how to do it now. Okay, so I would like to say thank you for your cooperation allowing, okay, jap. Sebelum tu I off lah video ni. Kita stop jap